get started here. So we're just going to take a little bit of time here. I'll start a clock. We'll take 2.5 minutes here. We're just looking at these tables, and we're just saying, is the table a linear or exponential function? Okay, so this is kind of what we did last class, so it's just a review of that. So I'm going to go ahead here and get the clock started, and you guys can ask me questions if you need, okay? So good morning, everyone who just joined. Good morning, everyone who just joined. Again, we're doing a little warm-up here. So there's two tables, and we're just trying to figure out if they are linear or exponential. All right. Hey guys, again, this is a warm-up. So if you came in late and didn't have enough time to work on that, I am sorry. Let's go ahead and take a look at this. And as always, if you guys have questions, let me know. And to the person who sent me a direct message, I think you're spot on. So let's just take a look at that and double check it. Okay. So good stuff. I appreciate you guys. I know you're working hard, and this is tough. So again, when we're going to test tables. What we're doing is we're looking at the input. Now, the change in x on all of these is 1, right? So I'm going +1, +1, +1, +1 on the x's, right, for all of these. So now, in a normal COVID year, we would take a look at problems where the x isn't going up by 1, but we're just looking at examples of where the x is going up by 1 every time, okay? So it gets a little bit more complicated when the x doesn't go up by 1, but we're not going to focus on that right now. What we are going to focus on is we're going to focus on the output. So remember, the difference between linear is adding and exponential is multiplying. Okay, so what we're going to do for these is we're going to check the output, and we're going to see, okay, as we go forward, are we adding by the same or are we multiplying by the same? Okay, so to get from 11 to 8, right, one trick, so I always do addition first, is to take the second number minus the first. So you're always doing the opposite of what you're looking for. So I'm looking to see if they're adding. So I'm going to do the opposite. So I'm going to have 8 minus 11. So when I do 8 minus 11, I get plus -3. So, and you can double check this. You can go 11 plus -3, that equals 8. Okay, so then we're going to take a look at this next one. So this next one again, I want to see what I have to add to 8 to get to 5. So I'm going to work backwards. I'm going to go 5 minus 8, and I get -3. So it looks like I'm also adding -3 here. It looks like I have a pattern, but I'm going to keep checking. 2 minus 5. Yep, that's indeed -3. And then right here, that is also -3. So what we have here, see how it's adding by the same amount every time? This would be linear. Okay, it's linear because we're adding by 3 each time. By -3. Right, so each new x value, right, each new input, say x was time, right? For every second, I'm decreasing by 3 each time. That would be an application of that, okay? And I appreciate people chatting with me. So if you guys have questions or you want to turn on your mic and ask a question, just go ahead, right? Because this is what we worked on last class. Is it linear? Is it not? Make sure you guys are doing your homework right. So I appreciate a lot more people got their midterm done. I think there's still 3 or 4 of you that haven't done your midterm. So we got to make sure we get that. I'm going to be sending out emails again today to remind people about that. But remember, your homework is worth 80% of your grade. So if you haven't done this assignment, make sure if you have questions to let me know and go back and do this assignment, okay? And then with this one, I'm going to look at the outputs again. So I always try adding first. So this is a really easy one to look at. How do I get from 1 to 2? It looks like I'm adding 1, right? But then 2 to 4, right? And again, to do this, I can just work backwards. 4 minus 2 is 2. I'm adding 2. And all of a sudden, my adding pattern seems like it's increasing, right? Which is a good sign that it's exponential. And if I go 8 minus 4, I get plus 4. And then if I go 16 minus 8, I get plus 8. And you can always double check this, right? 8 plus 8 should be 16. 4 plus 4 should be 8. But right here, it doesn't see how I'm not adding by the same amount every time. So this isn't going to be linear. So I'm going to try a different pattern. I'm going to try exponential. So for exponential, I have to think, okay, 1 times what gives me 2? So to do this, we can also work backwards. The opposite of multiply is divide. So I can take 2 divided by 1, and I get 2. So I could say, okay, 1 times 2 is 2. I could go 4 divided by 2 equals 2. And why am I dividing? Because I'm doing the opposite of what I'm trying to find. I'm working backwards. I know what the answer is. I want to know how I got there. So 1 times 2 is 2. 2 times 2 is 4. And then I'm going to go 8 divided by 4. That's also 2. And then I'm going to go 16 divided by 8. That's also 2. So notice how all the multiplication is the same. So this would tell me that this is exponential, because we are multiplying by 2 each new x value. Right? So imagine if x was time, what we're saying is as time goes forward 1 second, my output is multiplying by 2. A more realistic example of these, so let's say time was months or week. How about a week? If x was a week, I might be looking at bacteria, and that bacteria is doubling every week. Okay, that would be more likely. Okay, and that bacteria is growing and growing and growing, which is really important, right? That's why if something spills or you have something that's growing, that you clean it as quickly as possible, because it doubles, it grows exponentially. So if you don't clean that toilet now, it's going to be twice as worse in a bit, right? So sorry to bring up cleaning toilets. It's just something that I need to do today. All right. Are we okay, guys? The amount of conversation is at an all-time low today. We doing okay? You guys are. It's Thursday morning. It's cold, isn't it? Holy moly! It was supposed to snow, rain this morning. Did you guys get any snow in Skagit? Did you guys see anything? Yeah, I was looking outside this morning. I didn't see anything. My parents live up in the hills a bit, so maybe they got a little bit of snow. I haven't called them yet. You can only hope, right? You can only hope, especially right. There's no school anyway, so if it snows, you guys can just go outside and still be in class. And gosh, that would be fun, wouldn't it? All right. So today, guys, we're doing day 2 of exponential functions. So let's just review a couple of things about exponential functions. And I want to say I really appreciate, like, a lot of you guys are responding in the chat box. When you guys respond and interact, that's really good. So I appreciate that you guys are doing that. Thank you, thank you, thank you. So what are we doing today? So today is part 2. We're going to spend 3 days on this, right? So day 2 of this, let's just review. So what we've been talking about is exponentials. Exponential functions. Right? And exponential functions, the way they work is that we multiply by the same amount. Okay? And so that is different. Sorry, this is the same. It's like, come on, Craft, figure out your m's, right? My m's get really lazy. So multiply by the same amount. That's what exponential functions are. So we went from linears that were aligned, exponentials, and we're not going to get into graphing today, so don't worry about that. But exponentials look like this, or they look like this. Those are the basic ones. So these are two different, oops, and they should be crossing right here. Okay, so as you can see, that's not a line, and that's all I wanted to show you here. I don't want you guys freaking out about graphing. We're not going to get into that today. But what's important is that exponentials, right? They start growing really slowly. They start going really slowly, and then they take off really quick. Okay, and then this red one. And we're going to learn about this. After we do this. But one is decay and one is growth. And I'm just name dropping. You don't need to know these right now. But I just figured if I name drop them now, it will be less scary when we do them in next week. Okay. So decay. Take a look as we start really big and then it gets really, really small. Right. So decay is like radioactive isotopes, right? Like the radioactive means that it's literally breaking down and getting smaller and smaller and smaller. Okay. Whereas growth would be like that bacteria growing, right? And it's going to get bigger and bigger and bigger and bigger. Okay. So that's what exponential is. It's not linear. Okay. Things really take off or really shrink over time. Okay. Now, the equation that we have for exponentials is our base one is just y equals a times b to the x, like that. Now next class we're going to add a little bit more to this, but for right now this is where we're at. Okay, and we've labeled this before, right? So y is my output, B is my base, X is my input. Now this is deceiving and confusing. This has different meanings. So right now I'm just going to call this I'm trying to think of the words I can use because there's so many words for it. So in financial stuff, this is the initial amount, which doesn't make sense then if I go plus this, right? In geometry, this is called a dilation factor. So what I'm just going to say is that for right now, okay, I'm going to call this the vertical stretch. I'm going to call it a vertical stretch So the A term was not our focus for right now. We're going to come back to this. The A term is going to have different meanings for different situations. Does that kind of make sense? But what it does, do you see this graph? Well, if it was the A is just going to be a multiplier. So it just means that it would grow faster or it would grow slower. Okay? So think of it, right? It's like A could be an added fertilizer to the fungus, and so the fungus is growing a lot faster. Or A could be like, I took all the nutrients away, so then it's growing a lot slower. Okay? So that's what a vertical stretch means. It means it either is stretching up, so it's growing really fast, or it's stretching down and it's growing really slow. Okay? Now, remember for the base, this base right here, this is the amount being multiplied every time. So the base is really the most important part to an exponential, and that's what we're going to explore today. So the base, this part right here, and you know it's the base because it's underneath the input, right? See how the base is underneath the input? So that's the amount being multiplied each time. That's going to be our most important thing that we're going to be looking at. Okay. So the first thing that I want to teach you guys is how to do this in a calculator. So I'm going to show you how to do this on a physical calculator, but I'm also going to show you how to do this on Desmos scientific calculator, because I want to make sure what we're going to be doing is we're going to be evaluating, and each calculator has something slightly different. Okay. So let's take a look at how to evaluate an exponential function. And if you guys don't remember, you might want to add in there, evaluate is just a fancy word for plug in numbers. Okay, so evaluate just means we're not doing algebra, we're just plugging in numbers and seeing what we get. Okay. So I'm going to start with one, and then we're going to see what we can do here. Okay. So let's start with this one. So we're going to have y equals -2 times 5 to the x, where x equals 3. Okay. So let's break this down and talk about this because it's kind of confusing. What we have on the left here, this is our exponential function, right? Notice our base is 5. So what this means is whatever x is, that's how many times I'm going to be multiplying by 5. Then on the right, that's what we want to plug in and evaluate. So x equals 3. So if I plug in x equals 3 here, what this means is that I'm going to be going -2, and then I'm going to multiply 5 3 times. Okay. So there's a couple of different ways you can do this. Okay. Now the first is you could do this by hand. So what I would have here is I would say, okay, I have y equals -2 times 5, and then what I'm doing is I'm taking that 3 and I'm plugging it in for what used to be x. Okay. Do you guys see what I'm doing? I'm taking that x equals 3 and I'm plugging it in for the x like that. Okay. Now again, I'm going to show you a couple of different ways you can do this. Now in this case, do you guys see how the numbers are really small? Right? 3 is a pretty small number. So this is the same as -2 times 5 times 5 times 5. Notice here, this is 1, 2, 3 5s. Okay, so these two are equivalent. It's saying -2 times 5 multiplied by itself 3 times. Okay, so if I type this into a calculator, I get -2 times 5 times 5 times 5, and then I get what do we get? Y equals -250. Okay, so Now, the good thing about this is that you can do multiplication on any calculator. You don't have to worry about symbols. You don't have to worry about notations. The bad thing is, what if this number was 20? Are you really going to write out 5 20 times? No, that would take too long. And like, what if you didn't type in the right amount of 5s? That would be horrible. So there's got to be another way. Okay. So the first way I'm going to show you is I'm going to show you on the yellow calculator. So let's write that. So on So most calculators are going to be solved this way, okay, including this one. And I know some of you guys have this calculator because you checked it out from the school. So I want to give instructions on how to do this, and then I'm going to give instructions on how to do it in Desmos. Okay, so I'm going to be doing y equals -2 times 5 to the third power. Now, in calculator speak, this is what it's going to be. It's going to be y equals -2 times, and then you can do parentheses, and then you do this key right here. This is called a caret. Okay, and if you take a look on this calculator, it's right here. Okay, now, so what's going here? Do 25 times. You can think of it. So in this case, what's going on here is you have -2 times 5 to the third. So all that 3 means is that this number in the base is going to get multiplied by itself that many times. So so I don't know where you're getting the 20 from. So if I take a look at this, the -2 just stays because it doesn't have. Okay, so I mean, it's a good question. I just want to make sure I understand what you're asking. That's all, right? So if I have the -2, that stays, and then I'm just this part right here. I'm just doing this part right here, right? So 5 to the third means 5 times itself 3 times. Okay, so then in my calculator, I'm just going -2 times 5 times 5 times 5. Now, since it's all multiplication, order doesn't matter. So if you want to do -2 times 5 and you get -10, you'd get -10 times 5, and that's -50. And then you'd have -50 times 5, and that's -250. Okay, and we'll do more examples on that in a bit, and hopefully that helps you out. So again, for most calculators, it's going to have this button right here, and it's called a caret button. Now, you might have seen this button. You might have seen this symbol. Like if you have anybody in the military, this is used as a rank symbol in the military. Okay, and in the military, and in a non-math sense, this is called a chevron symbol. Oh my gosh, too much, right? Anyways, I'm just trying to show you this symbol right here. It means to the. So if I was to say this in English, I would say -2 times 5 to the, and then I would say third power. Okay, so let me show you what that means, and I'm going to try to show you my button strokes. So I'm going to start with -2 times, and then parentheses 5, and then I'm going to hit this chevron button. Now, there's 2 ways your screen's going to show this. If I do the chevron button, did you notice how my cursor changed? Look at my cursor. See how it's nice and big? I hit the caret button, and it goes really small. So I can type in 3 now. Okay? So then notice how they look the same. Now, if I go to mode, not all of you have pretty font. So if I did this without pretty font, it would look like this. Do you guys see that? So I'm just trying to show, because some of you have different calculators. Do you guys see how if it doesn't, it's called pretty print, doesn't make it look pretty, then it looks exactly like this. So I would read this as -2 times 5 to the third power. Okay? And I'm just going to go back here and put this on math print. And if I do that, then it goes back to automatically doing it for me, which I'm not going to lie is really nice. Okay, so then I'm going to get the same answer. So I get y equals negative 250. All right, so now what I want to do is I'm gonna add a layer here, and I'm going to okay. So for this next part, I'm gonna show you guys how to do Desmos. Okay, so this is how to do the Desmos. Okay, so in Desmos, it's a little bit different because the button is different. Okay, so in Desmos, I'm going to use the same equation. So I'm going to get y equals negative 2 times 5 to the third power. So in Desmos, the button that we want to use, and I'm trying to highlight this, is a to the b. Okay, so it looks like an exponential function. Okay, so then what I'm going to type in here is I'm going to go y equals negative 2 times parentheses 5, and then I'm going to hit the a to the b button and then 3. So let me show you what that looks like. So I'm going to go negative 2 times parentheses 5, and then I'm going to hit this button right here, a to the b. And do you see how it put me up to the top? Can you guys see that? So if I, what happens? Okay. So again, my cursor is just normal. I hit the a to the b button, and it does the same thing that the caret button does. And then I type 3. Okay. And then Desmos automatically shows me the answer. I get y equals negative 250. Okay. So it doesn't matter which way you do it. I don't recommend the first one. Okay. Does anybody have questions about Desmos? I just imagine that most of you are using Desmos. Are you guys okay with this? How I used a to the b? If you use a squared, it will automatically put a 2 there. Okay. So we don't always want 2. So that's why we do a to the b, and then it lets us type in the number we want. Does anybody have questions about Desmos? Okay, so I'm going to have you guys try one on your own. You're going to have to use one of these calculators to do it. So you're either going to have a calculator like this, or you're going to have a calculator like this. Okay, so let's try one of these out and see if you guys could do it, and then we'll move on. Okay, so I'm going to have you guys try this on your own. Okay, so try on your own. So we're going to try this. So you're going to have y equals 3 times 1/2. No, I want to write it as a decimal. I decided I want to write it as a decimal. Y equals 3 times 0.5 to the x power. And we're going to evaluate it when x equals negative 2. Okay, so I want you to use your calculator, and I want you to plug in negative 2 for x and tell me what you get. Okay, I'm not going to put a timer up because this should take about a minute. You're just going to use a calculator. You're going to plug in negative 2 for x and tell me what you get. Nice. So people are starting to get some answers. Can I get some more answers before we move on? Okay, sweet. So we're getting more consensus here. So again, I'm going to use my calculator here, and I always like to write it down before I plug it in. And the reason I do this, guys, because it gives me a visual of what my equation should look like. So that's really important. So when I go in here, I'm going to have 3 times 0.5, and then I'm going to go to the third power. Okay, so I look. Does this look exactly like this? Yes, it does. I hit enter, and I get 0.375. So out of all the answers people gave me, no one got this answer. Okay, so I'm gonna need people to take a look at what they typed into their calculator. Oh, I said -2. So I'm the one who's a jerk. Oh, guys. There we go. -2, right? So there's a classic example of me making a mistake, right? Okay, so -2. So I'm going to try this again. So I'm going to do -2. So does that look better, class? What do you guys think? Does that look a lot better? Okay, this looks better. So if I hit enter, I get 12. Oh my gosh. To think I doubted you. I was shocked. I'm so sorry. Y equals 12. All right. So so as you can see, even with calculators, you can still make mistakes, right? That's a great example. So and part of that is just making sure that you double check everything as you go. All right. All right. Excellent. So good. We're going to keep practicing this. I'm going to do one maybe that's a little bit more complicated, and let's see if we can do that. So let's try this. Let's do y equals, let's do 1/4 1 plus 0.7 to the x, and our x equals 3/4. Okay, so this one has a bit more numbers in it. It has some fractions in it. I just want you guys to take a second, type that into your calculator, and see what you get. I'm going to type mine into my calculator so I don't make a mistake again. Ooh, we got a decimal number. Hey guys, why don't we do this? Why don't you guys write your answer out to 3 decimals? How do you do a fraction in decimals? That's a great question. Let me show you. Okay, so in Desmos, to do that, I'm going to clear this. So it's this button right here, A over B. It's right above the enter. So A over B, you type that, and then it will give you a fraction. Okay, so the button is A over B right here. So I would go 1, and then you can use your arrow keys to scroll down to 4, or you can just click, right? You can click, or you can use the arrow keys next to your number pad. Okay. I hope that helps. So the fraction button, again, is just right here. You don't have this? Are you in Desmos Scientific? Here. Are you using the Desmos? So I know you're asking where the fraction button. Are you using Desmos? Because in Desmos it's just right here. It's above. It's right below the wrench. Okay, so again, we're running into issues, right, with using the calculator. So that's what this class is all about, guys. We're trying to figure out all our issues with our calculator and get good at it. Okay. Okay, so you don't have the wrench. So again, my question is, are you on the scientific calculator? What does your screen look like? So if you're on the 4-function calculator, you're not going to have it. So if you see this, we're on the wrong calculator. Right? So we go to Math Tools. If you click Math Tools here, we want Scientific Calculator. Okay, so this one right here. So when I click that, right, then it should be here. I also I put a link. So here, I'll send it directly to you. Make sure you're using that calculator. Okay. So, okay, good. Yeah, hey, and guys, this is why we're spending time on it, because technology can be frustrating. So let's go over this, because I'm getting people sending me different answers. So the beauty about this, and guys, if you don't have, okay, and I want to make this clear, if you don't have a calculator that does this pretty print where it looks exactly how it is here, if you don't have a calculator that does that, I'm going to ask that you don't use that calculator for right now. Okay. You can use it. It's still a good calculator, but for right now, when we're doing something like this, maybe Desmos will be better, because Desmos allows me to make it look exactly how I write it, which is awesome. Okay. And then I'm going to go to the, and then I can type a fraction again and go 3/4. So again, you want to make sure, guys, that when you type this in, what you type into your calculator looks exactly like what we have written down. Okay. Now, if I was going to write my answer to 4 decimal places, I would write 0.3722. So this is 4 decimal places. Okay. And your homework will tell you how many decimal places it wants. I have a feeling, knowing big ideas, I'm just looking at big ideas really quick. Sometimes big ideas wants 2 decimal places or 1 decimal place, but they will tell you in the instructions. If you're getting frustrated, you can send me an email and I'll help you out. Okay? Now, because not everyone got this answer, we got to keep practicing this. So again, if you have a calculator that doesn't allow you to see this pretty print, and what I mean is, if I go to mode and go to classic, what I mean by this is your calculator might do this. And you'd have to type it in like that. Do you guys see how that looks more difficult, right? I have parentheses, I have a division. It really is helpful to have it over here in the pretty format where it looks like it. So just for this section, I would recommend using Desmos if you can. All right. If you guys are having issues with your calculators, please let you know. I can deal with any calculator. I can help you out. Okay. All right. Let's practice a couple more of these, because again, some of you are like, Kraft, I get this. This is really easy, and that's good, but I want to make sure everyone feels like that. Okay, that's my goal. So let's do a couple more. So here we're gonna make a table. So to do this, we're gonna switch things up a little bit. Okay, so I'm gonna make a table. I'm gonna make a table with -2, 0, and 1/2. Okay, and I'm going to have you guys fill in this table. So we're going to say y equals 2 times 9 to the x. So what we're going to be doing is you're going to plug in -2 for x and tell me what your calculator tells you. You're going to plug in 0 for x, tell me what your calculator gives you, and you're going to get a 1/2 and tell me what your calculator gives you. Okay? So I want you guys to fill out this calculator. So right now what you're doing, here's my function for this table. You're going to plug these inputs one at a time for x. And you're going to do that in your calculator, see what your calculator gets, and then we're going to put those values in the corresponding y column. Let's see what we get, see how you guys do. So what are we doing? This is the function, right? 2 times 9 to the x, and these are inputs. So the first thing you're going to do is you're going to take -2 and you're going to plug it into your calculator, and you're going to write here what the answer is, right? Because y is the output. Then you're going to plug 0 into the x, and then you're going to tell me what your calculator gets. Then you're going to plug in 1/2 for x. No, thank you for asking. That's what this is all about. I'm not a YouTube video. This is class. Okay, and then let's just take a couple more moments, and then we'll go over this. I'm gonna even get this set up for a second. And if you guys like using your keyboard, the caret key is above the 6 on your keyboard. So if you hit Shift-6, it will do that quick command. So if you don't like using your mouse, that's a way that you can do the exponent on your keyboard. So that's just Shift-6. All right, I'm going to go over this. So the first thing I'm going to plug in is I'm going to plug in -2. Okay, now, ooh, that's a really ugly number, right? So let's go ahead and write down, before I did 4 decimal places. So this would be 0, and then my first decimal is 0, my second decimal is 4, my third decimal is 4, and then my fourth decimal is 6. Now, we have to be careful here. Notice on my fourth decimal, do you guys see this? My fourth decimal, to the right, it's 5 or higher, so I'm going to round that fourth decimal up. So I'm going to write that. Okay. So if your last decimal that you're rounding to, you always look to the decimal to the right of it, and if it's 5 or higher, you round it up, and if it's 4 or less, then you just keep it the same. Okay. Now, you guys see this fraction button right here? I could hit that fraction button, and I could write it as 2/81. Now, the reason why I wrote it as a decimal is because sometimes big ideas ask for a decimal, but if you're using Desmos, do you guys see this little button right here? It changes your answer into an exact fraction. So that the fact that you did 2/81 is perfect. Okay, I'm glad that you did that. I was just setting you guys up for a scenario where, hey, we have to round because big ideas wants a decimal. Okay, so that's what's cool about Desmos Calculator, is that you can easily do both. So very cool. Thank you for sharing. Oh, I love you guys. You guys are doing great. All right, so now what's really cool about tables is that I don't need to erase my whole function. I could just go highlight the -2 and hit, oops, apparently I can't do that. I'm going to have to redo this. So Shift-6 and then 0. And so I get -2 as my output. Okay, so notice how I just replaced my input with 0. Okay, it doesn't have the fraction answer because it's a whole number, so we're good to go. And then I'm going to go like this. I'm going to input a fraction. Oh, it did that thing again. That's really lame. Okay, so I want to make sure my fraction is up high. I get 1/2, and it looks like I get -6. Okay. And then can I get a little feedback from you guys? Are we doing okay? Are we feeling okay with this? Are you guys getting comfortable with your calculator? Did you guys get these answers? Why is it negative? That's a great question. So what happens with, okay, why is, no, it should be positive. Oh my gosh. Did I get, it should be positive for the other one too, shouldn't it? I don't know why I wrote negative, guys. Oh my gosh. There we go. Hey guys, don't hold back. Like, as you've seen, I'm human. and I make really silly mistakes. If you see me making a mistake, be a homie and let me know. Don't let me out. Don't hang out to dry. I'm so sorry about that. Yeah, obviously not. It doesn't say negative. Sorry, what happens is that on my screen, this equal sign is so small that it looked like a negative. I'm really sorry. I'm not used to using Desmos. So yeah, on my screen, this equal sign looked like a negative to me. I'm really sorry about that. So yeah, obviously they're positive because that's what you guys got. Okay, now are we feeling better? Thank you guys. And thank you for the people that wrote that in chat. I really appreciate that. Are we doing okay now? Is the calculator telling us the truth? Okay, good. All right. Hey, let's do. We have time. I'm gonna do one more of these, and then we're gonna call it good. So I'm just going to pull out all the stops. We're gonna make this one more complicated because if you can do this one, you can do everything. So again, we're going to have a table with -2, 0, and 1/2. So we're using the same inputs, but what's going to change here is the equation. So I'm going to give you an equation, and this is the ultimate test. Can you use your calculator? So let's try this. It's going to be 4 times 2 to the x minus 3, and then plus 2. Okay, the x minus 3 is all on top. So I want you guys to give this a try. Can you plug this into a calculator? And yes, this is as difficult as it can get with using your calculator. Okay, so all you need to do is get this into your calculator and then replace the x with -2, and then do it again with the x being 0, and then do it again with the x being 1/2. Give it a try. See if we can do it, because if you can do this, you can officially say that you have some mad calculator skills, which I'm sure will get you all the friends. You're gonna have like 50,000 followers on Twitter or Instagram. Okay, and then I'm gonna start typing this too. Ooh, that's hard. Does it not let me do that? Ooh. So in Desmos, guys, you might have to put parentheses around it. Okay, so you might have to put parentheses around it in Desmos. Like that. Does that help people out? Were people getting frustrated there? So you might have to put parentheses around it and then come down to do the +2. And it's giving me a warning sign because I can't have x, right? I just need to, at this point, I need to replace the x with a number. So Desmos makes us put parentheses around the top. All right, hey guys, it's 9:49, so I can't give you any more time. So I'm just going to go ahead and do these, okay? So if you didn't, you can follow along. So my first one I'm going to plug in is -2. So I have -2 on there. So I got positive 2.125. Okay, don't leave yet. Class isn't over. Okay, and then I got 0. I got 2.5. And then I plug in, see, this is really easy with Desmos. Once you get that first part, I'm going to make this into a fraction. I'm going to go 1/2, and then I get a really ugly number. So 2.7071. All right, before you guys leave, just a couple of quick announcements. One, if you haven't do your midterm, you need to email me at this point. 2, make sure you guys are doing your homework assignments. Remember, it's 80% of your grade. There is no penalty for late work, so make sure you get that work done. It's just straight points. Second, if you want to redo any assignment, just email me the assignment name and I can unsubmit it so you can work on it again. Okay? And then 3, make sure if you guys need help that you either email me or come see my office hours. Okay? So I'm going to turn off this live stream.